Okay, welcome to lecture number 5, and today we are going to have some, solved examples regarding the roundabout, the design vehicle accommodation check. Uh, so basically, the objective of this task is to check to see if the geometry that the design of this roundabout allows a design vehicle to go through. For this purpose, I'm going to present to you 3 examples from different places. So these are the examples that I have selected. These are 3 roundabouts. These 2 roundabouts are from Khobar, okay, that we discussed in the previous lecture, and also this one is from Raleigh, North Carolina. It's a small roundabout, so we're going to start with this roundabout. Just to give you a background about this roundabout, this roundabout is next to North Carolina State University. So it's in the city. It's not in a commercial area. It's almost in a downtown. So you are not expecting to have heavy vehicles, like 18-wheelers and stuff like that. However, buses are very common in this area because they use the transit bus for students transportation. So we are going to start using AutoCAD and the tool that I was talking about yesterday, which is Cad Tools. In order to use this tool successfully, you have to draw a trajectory, a polyline, okay, for the bus or for the design vehicle. So we are going to start here and draw a reasonable trajectory, okay. We're going to say this is arc, and try to see if this design will allow for this design vehicle to go through. So we are going to assume that the design vehicle is going this way. Okay. Okay. So this is our vehicle trajectory that we plotted. So then we go back to this tool, Cad Tools. You can download it, it's free, and select the vehicle turning simulation from here. So here we select the design vehicle that we want to test to see. So I'm going to select this H2 bus 45, okay, and I will click execute. Then it's going to ask me for vehicle trajectory. Now it's calculating and simulating, then start plotting. Okay, now it's done. Look here. So here we can see that the bus worked fine in this scenario. Okay, so you can see here the green lines represents the wheel tracks. Okay, as you can see here, that's the bus in different phases or in different stages of the maneuver. Okay, and here the green lines represents the front wheel track and the rear wheel tracks. So we can see that the design can accommodate the H2 bus 45. Okay, so this one is okay. Let's check to see if an 18-wheelers, okay, can go through. I'm gonna save this one. I'm gonna just make another copy here. And I'm gonna erase this. Then I'm gonna go back to the CAD design tool and select another design vehicle. Let's select the Ashto 65. The Ashto 65, that's a very common 18-wheeler. It's not the longest one, but it's, I think this one, I think it's very common. So let's see if an 18-wheeler can go through this roundabout or not. Okay. It seems that it got stuck here for some reason. Okay. I think the trajectory needs to be re-edited because it's requiring some geometric modifications. So I will go back and just just erase this one again and tweak the minimum radius. Let's say the maximum angle of rotation. Let's change this to be 35 and say execute and turn here. Okay. Okay. So now you see that here the wheel tracks are going over, crossing more than the apron. So does this mean the design is inaccurate? No. Basically, what we need to do, just move the vehicle trajectory a little bit further. Okay, as you can see, this marked area, there is no obstacles here. Okay, and I think it was meant for this part for cases like this. Okay, I'm gonna just move it here. Let's reiterate on this one and try to okay. As you can see, now the wheel tracks are avoiding, I'm sorry, are avoiding the island. Okay, but they are going through over the apron, so the apron here is functional. Okay, so that's let's now try on this roundabout in Khobar. So we're gonna draw uh, the vehicle trajectory, okay, for the truck. Then we will see. I don't think we will have any problem with this roundabout because it's already, you know. So now we are simulating a truck that is going through the roundabout. and let's see how it will perform. So we're going to take the same 18-wheeler, the H2WB65, and let's try it. Okay, it's done. Let's have a look. As expected, because the diameter here is, the roundabout diameter is large. So there was no problem with the wheel tracks. And as you can see, it went through smoothly and with no problems. So for truck accommodation, this roundabout is very good. The same we can apply here, and we can check, and I don't think we'll have any problem also, because as I mentioned, the circulatory way here is wide. We have here maybe 6 lanes or something. So if we plot a vehicle trajectory, okay, okay, let's see for this design vehicle. Okay, for this design vehicle, as you can see, there was no problem, and we didn't need any, apron or something here. That's clear? Okay. Actually, I noticed something while I was, doing this for this roundabout. Let me just have a copy of this, and let's have a look at something that I observed. Try to look carefully at this scene. What do we have here? We have a vehicle entering, okay, or waiting to enter, already entered, okay, and there is no entry line for this roundabout. So that's one of the problems of not having an entry line for the roundabouts. It exposes others to risk of accidents.
Doctor,
Yes,
I think many of roundabout like this, Doctor.
not many. That's almost all of them.
Yeah.
Yes.
Why, Doctor?
Why? The standards and specifications for modern roundabouts are not very clear in here. And for that specific purpose, okay, this is going to be, the assignment for, for this module. I'm going to give you the assignment to evaluate a group of roundabouts. Let's go through this assignment and have a look at at this assignment. Okay, so now I have attached 13 images for different roundabouts. Okay, the roundabout assigned to your name is shown in the list below. So you will find your name and you will find a roundabout number. Okay, what you are supposed to do for this roundabout, you are going to prepare a report that you are going to make all the assessments that we discussed here. You are going to make assessment for a general features of the roundabout. Then you are going to assess the entry speed, the size and the lane alignment, the heavy vehicle accommodation, exactly similar to what I have done now, the pedestrian safety. Have a look at the roundabouts that you are supposed to be, you know, solving. That's the compressed file. And these are the roundabouts that you are supposed to work. Okay, they are missing some roundabouts. Just to give you an idea on these roundabouts and what you are supposed to do. These are images captured from Google Earth. Okay, that's the scale. You have to scale the drawing, and that's the roundabout. You have to review it from the entry speed, from the dimensions, from the handling of pedestrians, from the splitter islands, okay, from all the characteristics that we discussed before. Or
نعدل
discussed.
الأخطاء اللي فيها دكتور ولا كيف؟
Exactly. That's what you are supposed to do. And also you have to assess the entry speed for the roundabout. Okay, and do the same with that what we have done now for the heavy vehicle accommodation. نعم.
لا بس أضفت إن تراك accommodation.
Yes, the truck accommodation. Okay. So
دكتور
this, yes, hold a second, just please.
تفضل.
That's also another roundabout. Okay, and so on. Yes, you had a question. Go ahead.
بالنسبة للسبيد الانتري سبيد نسويها عن طريق الكيرفتشر ذاك، نرسم
Yes.
كيرف
Yes.
ونشوف الأبعاد ونسوي تشيك يعني.
Yes. First, you have to grab this image, okay, and scale it. Okay. Let me solve one example for you. Let's take this one. Let's go to AutoCAD. This can say. So that's a roundabout. Okay. Actually, it's not the best, but okay, we need to scale it. So in order to scale it, we have to go here and measure this bar. This bar, it's 2.3 something. Let's annotate. Measure the dimensions. So that's 2.32. Okay. So 2.32 and here is 63. So divide the 63 over 2.32. So this image needs to increase to 27 times. So home, scale this one. 27.15. Now it's to scale. So you want to check, draw a line from here to here. How much we have? We have almost 63. So this way we are in good shape. Then you are going to determine here, okay, draw a polyline from here we start. So that's okay. What's the entry radius? Let's measure. Okay, annotate, and let's measure the radius. So the radius here is 187. Okay, then you can use this value, convert it into feet divided by 0.30, and get the speed from, or you can calculate it using the equation that we discussed we discussed yesterday. Okay, so that's one check for the entry speed. And of course, you can say that, okay, there is no deflection in the splitter island here. And also, this splitter island does not prevent vehicles from making wrong way maneuver, okay, and so on. There is no pedestrian crossing. There is no entry line. Then you can check also for the heavy vehicle. I don't think the heavy vehicles will be a problem here because the diameter already is large. Let's look at the diameter of this roundabout, and let's measure it from here to here. It's 97, so it's within, the limits. Let's aligned. So it's from here to here, for example. So that's 91 meters. Okay, that's within the limit. It's acceptable. It's not very large. Okay, so it's expected to. But if you look here for the lane alignment, for the splitter island deflection, all of these aspects are not there. That's an example. Any questions?
It's clear now.
Okay, sounds good. And while you are working, if you have a problem, you can just contact me, and we will. I can give you some support on that and some help. Sounds good.
Yes.
Okay, the due date for this project is next week, inshallah.
Is the deadline next week or
Yes, the deadline is next week.
same day, huh?
Yes,
Thank you, Doctor.
you're welcome. Okay, Shabab, any questions?